This video is part of the Microsoft Virtual Academy. In this session, we're going to understand all of Microsoft's different high availability solutions. And there are many products that fall under this category of high availability. There are some more traditional ones, such as failover clustering or network load balancing. But beyond that, we need to think of any type of solution that both provides redundancy and high availability in a broader scope. And so this means we're also going to include such technologies as round robin, backup and restore, and replication. I'm Simon Perryman, and part one of this session is going to cover high availability by looking at the infrastructure there. So what exactly is high availability? Well, high availability means that our critical systems and servers are kept up and running. The goal of high availability is to provide these services all the time, known as continual availability, and to eliminate every single point of failure. Now, the way that high availability is quantified is known as the number of nines that it has. So if you have 5 nines of uptime, which is 99.999% of uptime, that's equal to only about 5 minutes of downtime every year. Now, this is what most organizations strive to get for their critical services. However, if you have your services running on a single machine, this is going to be very hard to achieve, simply because a single reboot will probably take up that 5 minutes. So if you're doing reboots once a month or every couple of weeks, you're definitely going to go beyond this limit. We generally see most organizations at about 3 nines of uptime. However, there are many new technologies that have just come out in Windows Server 2008 R2, which allow customers to push the limits and approach this goal of 5 nines. High availability is important simply because server downtime is unavoidable. The world is a 24/7 marketplace, meaning that any time that a service is down, customers can be lost. And there are many reasons why a server can become unavailable. This could be due to maintenance, such as repairing a server. It could be an upgrade to the software or the hardware. It can be an update to fix an issue or apply a security patch. Or it could be caused by some type of accident or disaster. So start planning now. Be prepared to have the highest resiliency in your infrastructure as possible. As we've mentioned, Microsoft's high availability solutions cover a broad range of technologies. It covers the infrastructure, the application, and even the management layer. You can make almost any technology highly available, but this particular module is going to focus on infrastructure high availability, which is looking at how we can add resilience to the physical data center, the hardware, the core server infrastructure such as Active Directory and networking. Then on top of that, we're going to look at failover clustering and Hyper-V virtualization. Module 2 is going to focus on application high availability, and the third module will look at high availability in the management layer using the System Center products. Let's take a look at the core infrastructure and first talk about site resiliency. Site resiliency means that you're planning not just to survive a particular disaster at a local site, but to be able to move across sites so that your service can be resilient even if you lose an entire data center. Now, losing an entire data center isn't very common. However, consider times where there's been a natural disaster, such as a hurricane or a flood. Or think of times where there's been a regional power outage. These things can happen. So by stretching your services across multiple locations, you can have higher resiliency. There are 3 primary technologies which are used to provide site resiliency. The first is failover clustering, which we're going to talk about a little later, that allows you to actually fail over services between different sites. You may also use replication, which allows you to have copies of the data at multiple locations. So if one site is unavailable, the data should still be available and accessible in a different location. The third type of site resilience high availability is using backup and restore. This means that you're constantly taking copies of the primary data from the primary site, and if that site becomes unavailable, you could go and restore the data from another location to bring the services back up. However, one key thing that we want to highlight is that you should not rely on people during a disaster. You need to automate the solution because people can be unreliable when there's a critical situation. If there's a data center and water's flooding the place, you don't really want to rely on people to be failing over your virtual machines. Those people are going to be leaving the data center. They're going home to take care of their families. And so you really need to take the people out of the equation and focus on a completely automated solution. This could be faster, reducing the amount of downtime. It can simplify the complexity of the plan. It can automatically synchronize the changes between the sites to ensure data consistency. Now, oftentimes people may need to be involved in the decision about when and how to restore the services. But when there's a critical outage, it's often best to just get the services up and running and then deal with some of the smaller problems later. Next, we're going to look at the hardware high availability. And the key concept here is to eliminate any single point of failure and to add redundancy everywhere. Anytime you have a single component that your end-to-end services rely on, losing that component means you lose your end-to-end services. So as we think about the entire data center, we look at the network, we look at the power, and we look at the storage. With network, we want to have hardware load balancers in place, and these will distribute the traffic amongst multiple servers. You want to have NIC teaming, which provides redundant inputs to a specific NIC or to a specific server. You want to have redundant networks and redundant networking infrastructure with the switches and the routers, so that if you lose a single component of this networking infrastructure, the entire solution can still remain online. And don't forget, this also includes having redundant internet connections to your data center. Again, we want to eliminate that single point of failure. So speak to your ISP and make sure that you even have redundancy on connecting to the public internet. With power, it's important to have backup generators or backup battery supplies. This way, in the event of a power outage, you can still keep your services in your data center up and running. And when you keep these servers up and running, also have redundant power supplies that actually go to the servers or to the networking devices themselves. This way, if there's a problem with an actual power strip, you can still keep all of your services up and running because they have a secondary power source keeping them alive. As we move to the storage, we look at high availability by using a few technologies. The first can be done using mirroring and replication. This essentially means you have redundant copies of the data that are kept synced in different physical locations. You want to have multipath I/O or MPIO, which can provide redundant paths to your actual storage fabric. And then of course traditional RAID, just built-in redundancy in the actual disk arrays themselves, so that if any disk component becomes corrupted or inaccessible, all of the data can still be recovered. Now, we also mentioned iSCSI target high availability, and as we look more broadly, we can actually use any type of storage area network in our private cloud environment for high availability. However, the advantages of using iSCSI are that we can have high availability both for a physical cluster and for a virtual cluster. Because today, iSCSI communicates over Ethernet, and so there is no requirement to have a virtualized HBA running from your virtualized infrastructure to your physical storage disks. As we move on to a next level in our infrastructure, we have to consider Active Directory. Active Directory is often going to be a requirement anytime you build out a highly available infrastructure. One of the reasons for this is that failover clustering actually requires Active Directory to bring any type of service online on the cluster. So if you plan to use failover clustering as one of your high availability technologies, Active Directory will be a requirement. As you may know, there are 5 primary Active Directory roles. Most of these use redundancy as one of their high availability techniques. This way, if a single Active Directory server is unavailable, services can continue to run. And consider redundancy if you're also planning for branch office solutions. If you have your primary data center and a branch office, and that branch office doesn't have any Active Directory infrastructure, it's possible that a disconnect in the network between the primary site and the branch office could take down that entire branch office if it can no longer access Active Directory. Now, as we go down this list, we are going to start by looking at Active Directory certificate services. And the primary high availability technology here uses failover clustering. And there's a white paper available today that shows how to cluster ADCF on top of Windows Server 2008 R2 failover clustering. Active Directory domain services is the most commonly used piece of Active Directory infrastructure, and there are a few different high availability solutions. First of all, there's a feature in Active Directory called Recycle Bin that allows you to restore accidentally deleted Active Directory objects for a certain period of time. So having this option in the back of your pocket gives you a few different ways to actually recover any type of accidental deletion or to recover from any previous type of synchronization issue by simply pulling back an AD object back to the state that it should have been in. Active Directory domain services also use backup and restore technologies, and it can use a load balancing to distribute traffic across the different ADDS servers. Now, as we go back to talk about this branch office scenario, read-only domain controllers are an interesting solution. With a read-only domain controller, you have access to the information in your Active Directory infrastructure, but you cannot make changes to it. So this can be a very nice solution in a branch office where you need it to function correctly. However, you don't need to make any type of authoritative change from that branch office. However, one consideration to keep in mind is that read-only domain controllers do not support failover clustering. A cluster actually needs access to a writable domain controller. Active Directory federated services have two different solutions for high availability. They can use replication across different sites. So if you have a federated service in Contoso and a federated service in Fabrikant, you can use replication to keep these two domain controller databases in sync. And then for the actual database itself, you can use SQL mirroring, which is another type of replication technology to keep the information consistent across the sites. Active Directory Lightweight Directory Services, or AD, LDS, gives you two similar features as well. It has the same cross-site replication technology, but it also has some built-in backup and restore solutions that you can use to save the state of the database and then restore it at a later time if necessary. Active Directory Rights Management Service has two different features as well for high availability. First of all, for the licensing server role, it can use network load balancing to distribute the traffic across incoming servers. This way you can avoid overloading a particular licensing server to keep the licensing server infrastructure online. Additionally, for the RMS database, you can use multiple SQL Server high availability technologies, which could either be failover clustering or it could be log shipping. And there's more about these different SQL HA solutions in the second module. One of the key tips and tricks we have is to tell you, avoid putting your entire AD infrastructure on a Hyper-V failover cluster. While this is supported, you have to keep in mind that the cluster requires access to Active Directory to bring anything online. Now, this means that if you place your domain controllers inside virtual machines which run on the cluster, and the cluster shuts down, you might not be able to start the cluster up again. Remember, the cluster needs access to Active Directory, but Active Directory doesn't yet exist until those VMs are started. So you could put yourself in a service startup deadlock. It's always a best practice to have at least one domain controller on a physical server to avoid any type of deadlocks. As we continue to talk about some of the networking components, we look at the domain name services high availability. The primary technology used here is known as DNS round robin. DNS round robin allows you to distribute the load across multiple front-end servers. Let's say, for example, you have 5 front-end servers that support your website. Each of these servers are identical, and so they're going to register their DNS records in DNS. And this DNS server will now contain a list of the 5 IP addresses for those front-end servers. Whenever a client connects to DNS and looks for any of those servers, it's going to get the next one in the list. This way, we distribute the traffic in a pretty simple algorithm to each of the servers, one at a time. So the first 5 connections will go to 5 separate servers. The 6th connection will go to the first, the 7th will go to the second, etc., to help load balance all of this traffic. And in reality, this is not quite true high availability, but it is redundancy. If one of those servers becomes unavailable, we can simply redirect traffic to another one in the list. Our final networking technology that we are going to cover is network load balancing. And with this technology, we distribute the traffic across multiple NLB servers. You're going to use NLB anytime you have stateless servers with identical data. And the reason for this is that there's no shared configuration information between the servers. So as long as one of those NLB servers is up, all of the information can be accessible. From the client's perspective, this looks like a single large server. When the client connects, they're going to make a request, and once that IP packet gets to the router, it's actually going to get sent to every node in the NLB cluster. It's going to go through the NIC Mini port driver, through any other filters in the networking stack, and finally end up at the NLB filter. At this point, all of the nodes in the NLB cluster speak to each other. One of them agrees to take this client's connection, and the others will drop it. At this point, we say that the client has affinity with one of the servers, and so long as that server remains up, the client will stay connected to that server, and any information within that session will simply go back and forth between that same client to that same server. If this server becomes unavailable, the client will get redirected to another server in the cluster. Network load balancing uses a relatively simple algorithm. It filters at the level 2 of the networking stack, so there are some limitations around how it can be used. A best practice is to try network load balancing anytime that you have stateless information. Again, this means that each of the nodes in the cluster are deployed identically and there is no shared information between them. NLB is free in all editions of Windows Server, so it is often much cheaper than purchasing hardware load balancers. However, oftentimes you do need to share information across servers and have a single consistent database or set of source files, in which case you are going to go and use failover clustering as the high availability technology. Failover clustering is essentially our key server infrastructure anytime we need shared data. And as a result of this, there is a requirement to use shared storage on a storage area network. This means that all of the nodes can simultaneously access this data on the shared network. So if a virtual machine is running on node 1 or it is running on node 16, it always has a consistent view of the application's data. And when we talk about data, if this is a virtual machine, this could be the VHD file. If this is a file server, this could be the actual shares and the files that are being hosted. If this is a SQL database, this would actually be the database itself which is on that shared storage. This way, any node can access it, and we always get a consistent view. But redundancy is one of the key factors here, or really any time you're designing a high availability solution. You want redundancy everywhere. You need at least 2 servers, which we call our cluster nodes. You need at least 2 NICs and dedicated storage adapters. You want to have multiple networks. And again, this is for the added redundancy and added high availability. You want to have separate networks for each of the different roles in the cluster as well, to help separate how the networks are being used for certain type of data. You want a dedicated network for the public connections. This is where your clients are accessing information and connecting to your services. You also want to have an internal network that is used for the internal cluster communication, such as updating cluster databases, understanding cluster membership, or doing health check between nodes. If you're using Hyper-V, you want to have a dedicated network for live migration. Live migration is a technology which copies a lot of memory across a network as fast as it can, and so we want to avoid having that network flooded and impacting that network's availability for other users. It's also recommended as a best practice to have a dedicated network for Hyper-V management. So this would be actually managing the physical host, or even doing things such as copying files from your library server to that host. If you have storage that goes over Ethernet, such as through iSCSI or Fibre Channel over Ethernet, again you want to have a dedicated network for the storage to make sure it does not impact any of the other networks. And if you're using backup with Data Protection Manager, again, it is recommended to have an isolated network for this, so that it does not interfere with other traffic. One of the primary reasons why we want to avoid having traffic interfere with each other is that we do not want to trigger any false failovers. The way the cluster health check works is that each of the nodes send pings to each other across the internal cluster networks. So long as the other nodes respond to those pings, every node in the cluster stays healthy. But if a node is unable to respond to pings, and this can happen when the pings cannot get through the network, other nodes may think that this server is down and trigger a false failover, which we want to avoid. So isolate the networks and avoid having any type of traffic impact any type of cluster health checks. Let's take a closer look at exactly how a cluster works. In this scenario, my server on the left is hosting several virtual machines, a file server, and a database. The network at the top is the public network, and some of the clients are connected to this server on the left. In the middle I have my health network, my heartbeat network, which is what the nodes are using to check that each other is still healthy. And on the bottom I have my storage network, which could be using either iSCSI, Fibre Channel over Ethernet, or if we're using a dedicated storage network, it could be using traditional Fibre Channel or serial attached SCSI. This is where the application's data is, on the shared storage. The server is running the service, and the clients are connecting to that server. In this scenario, we're going to have a crash, and our node becomes unavailable. In this case, we're no longer accessing the data, and our clients are no longer connected. Health checking is going to kick in, and the node on the right is going to detect that the node on the left is no longer available. Since there's a shared database between these servers, every node always knows what every other node is hosting at any one particular time. So this second node, it knew that the first node was hosting a couple of VMs, a SQL database, and a file server. It knows that all the information for these workloads are stored on the shared database. This means that the second node can simply access that shared storage, start the services that it knows the first node was running, and then allow clients to reconnect. This is what we call a failover. We're simply moving the applications and the services from one server to another server while still accessing a consistent source of data. And with a cluster, you can have multiple active nodes. So it isn't just an active-passive configuration, such as in this example. Every node can be running workloads. But it is important when you're doing this to keep capacity planning in mind. You don't want to overcommit a particular host and cause that to crash. It's much better to distribute the traffic or distribute the workloads across all of the nodes in your cluster, yet still ensure that you have enough remaining capacity so that if any node becomes unavailable, the other nodes can still host its workloads. With failover clustering, you can cluster just about anything. The most common roles that we see clustered are Hyper-V, SQL, Exchange, and File Server, and these count for more than 90% of all the clustered services and applications. However, there is inbox support for many other server roles and features. But if that's not enough, you can actually have full customization for all of your clustered workloads on a Windows Server failover clustering. Now, this is available not just for other workloads and Microsoft products, but also for any third-party applications. Now, there's two ways to do this. You can either write a resource DLL, or you can use a generic container. A resource DLL is essentially a mapping of operations for what the cluster wants to do and how a particular service or workload should behave. So, for example, a cluster operation would be to online a workload. How that workload is actually started would depend on the specific workload, and so there needs to be some mapping to tell this specific workload that the start command would be net start service name, for example. And having this series of mappings between a cluster operation and between how the workload functions enables this workload to become a first-class citizen in the cluster. If writing a resource DLL is not an option, then using a generic container might be a great solution. A generic container is essentially an extensible module that allows customization through a wizard. So anytime you have an executable application, a script, or a Windows service, you can actually make that cluster aware using a simple wizard. It has health detection, and it can fail over to different nodes. Let's move on and talk about Hyper-V a little further. Now, as we mentioned, Hyper-V's primary technology is failover clustering, but there are still several other high availability solutions which can be used with Hyper-V. First of all is load balancing. Hyper-V can use network load balancing either within a host or across multiple hosts. However, one consideration to keep in mind when using Hyper-V and network load balancing is that you actually have to explicitly enable a feature in Hyper-V to allow MAC address spoofing. And this essentially tricks the virtual switch to make it work with NLB and to send the packets to every single NLB node in the NLB cluster. If you're load balancing across hosts, this can be limited in its functionality because you need to ensure that every switch as part of that networking infrastructure also supports MAC address spoofing. If it does, then you will be able to load balance across different hosts. However, you always have the option of using hardware load balancing, and you can balance that across different nodes and different hosts without a problem. Replication is another commonly used technology with Hyper-V, where you're simply copying VMs to another location, and this could be a cheap and effective disaster recovery solution. Additionally, you can use more traditional backup and restore technologies, where you can save a running virtual machine, and you can restore it on the same host, on a different host, or even in a different location if necessary. But Hyper-V primarily uses the failover clustering technologies, so this will be our focus in this module. With failover clustering and Hyper-V, this is really the foundational infrastructure of the private cloud. The products are tightly integrated, and you can even manage Hyper-V directly through Failover Cluster Manager, so there is no need to go and launch multiple administrative consoles. Now, not only does failover clustering give you higher availability for your virtual machines by providing failover, but it also gives additional health detection. There's an option that you can enable in Hyper-V called heartbeat monitoring, which will actually allow the Hyper-V host to monitor each Hyper-V virtual machine and to restart that VM or to fail that VM over to another node if the OS of that VM bug checks or blue screens or there's any type of user mode hang. So we're not just detecting the VM itself, but we're detecting the operating system within that VM. Again, we have the automated recovery as well, but think of high availability and virtual machines with clustering as not just high availability, but it enables mobility as well. If you need to do any type of maintenance to the host, you have a very easy opportunity to go and move that VM to another host. And using the technology known as live migration, you can move that VM to another host with zero downtime. Now, as you think of the scale, failover clustering supports 1,000 VMs per cluster, or 380 VMs per node. This means that with just a 4-node cluster, you can actually have 1,000 VMs, or 250 VMs on each node. Now remember, you always need to keep this reserve capacity in mind. If one of those nodes crashes, those VMs need to go to other hosts, yet you still need to make sure that you are within the limit of 384 VMs per host. Now, if you're using 4 hosts, they currently have 1,000 VMs distributed across them. That is 250 VMs each. If you lose a host, each of those nodes is then going to be hosting 333 VMs each. So you still stay within your limits. But when you're doing this planning and you're configuring your first Hyper-V cluster, it's best to test all of the VMs with in-production workloads, because oftentimes you will find that you cannot even scale to the maximums even if you wanted to. Now there are 2 different types of clustering that can be done with Hyper-V. Up to now we've been talking about traditional failover clustering, which is known as host clustering. In this situation, the cluster runs on the physical hosts, VMs move between different nodes, and you could use any of the 4 type of shared storage technologies which clustering supports. This type of clustering is going to be the same type of clustering that you will see if you're using high availability with SQL, a file server, or with Exchange. We move things between different hosts. However, with virtual machines, we have to keep in mind that we can extend the concept of what a server is into the virtual layer as well. If we have Windows Server installed in a VM itself, we can actually cluster it as well. This is known as guest clustering, and in this scenario, we're actually clustering the virtual machines. What's running inside the virtual machine could be a SQL database, it could be a file server, and that component will actually move between different VMs. So if you need to patch a virtual machine, or a virtual machine crashes, the service can fail over to a different virtual machine. However, one of the limitations here is that you must use iSCSI only. And the reason for this is iSCSI communicates over Ethernet, so it's easy to go past the information from the VM to the physical disk, and there are no requirements for a virtualized HBA. We often get asked, can I combine both host and guest clustering? Absolutely, this is fully supported so long as it passes the cluster's best practice analyzer, which is known as Validate a Configuration Wizard. This gives you the advantages of having high availability and mobility between physical servers and virtual machines. You can patch any physical server and live migrate a VM to a different physical host. You can patch any virtual machine and fail over an application to any other virtual machine. You can mix any combination of physical and virtual nodes so long as the entire solution passes the validation tests. As we wrap up, we've covered a range of key infrastructure high availability technologies, from looking at Active Directory, to networking, to site planning, and then some of the core features of failover clustering and virtualization with Hyper-V. Remember, downtime is inevitable, and high availability is a critical component of any data center. Stay tuned for Module 2 as we go and explore application high availability, focusing on Exchange Server and SQL Server. And Module 3 will talk about management high availability, looking at the System Center products. Thank you. This video has been part of the Microsoft Virtual Academy.